Okay, well, we're back, and in the last video we learned how to define the tangent of acute angle via right triangle similarity. In a similar way, we're going to define the sine and the cosine in this video based on an acute angle. In this case, we're still going to work with our 40-degree angle that we started with as we did in our class project. And remember, what we did is we picked any point D that we wanted out here, and from that we drew a right triangle. Then we can measure that side. We could also pick another triangle, doesn't matter where we pick the point D or whether we call it point F, as long as we make a right triangle there where we have a 40-degree angle in the triangle, then that identifies an opposite leg, an adjacent leg, and the hypotenuse. Measure those three sides, and we found that the ratio of the opposite side to the adjacent side, in other words y over x, if we label them this way, is the tangent. In a similar way, we can define two new functions, the sine and cosine function. The sine function is the length of the opposite leg over the hypotenuse. So that would be this side here, the y value, or GF, divided by the hypotenuse, which is this from B to G. So in our particular measurements right at the moment, GF, or FG, is 5.42, and the hypotenuse, which is BG, is 8.43. So we divide 5.42 by 8.43 right here, and you'll see that you get 0.64. And it really doesn't matter where we put this triangle, how big we make it, it's the same ratio the whole time. That's very important. So ultimately, what does this ratio depend on? It really depends only on this angle. Now, of course, we change that angle, we get a different ratio. With 30 degrees, we actually get a half. With 20 degrees, we're going to get an even smaller number. We can get a big angle, like 79 degrees, and we get a bigger number, 0.98. Okay, let's go back to our 40 degrees that we started with. So it does depend on that input of that angle, but it does not depend on the size of where we pick the triangle. So again, if we pick a number, say 50 degrees, we get a different number for this ratio, 0.77, but it doesn't matter which triangle we pick here, we still get 0.77 every time. Okay, so that is a function. The input, as we change the input, we get different outputs, but only one output for every input. So if we can draw our angle, whatever it is, for an acute angle, go out somewhere, anywhere we want, pick a right angle there, go up and see where it reaches the other side, we have a right triangle. Then we can measure the opposite side and divide it by the hypotenuse, the length of the opposite side by the length of the hypotenuse, y divided by r, and that gives us what we call the sine function. We use r because eventually we're going to see that we're going to think of this hypotenuse as being the radius of some circle. And we use y because in our standard orientation, this side here, the initial side is horizontal, then the opposite side being perpendicular to that will be vertical, and the adjacent leg will be horizontal, and we typically use y for vertical distances and x for horizontal. So sine is then y over r, or opposite over hypotenuse. And we're going to go ahead and define one more, which is cosine, and cosine is then the adjacent leg, the length of the adjacent leg divided by the hypotenuse. And in this case it's 0.77, so it's x over r, or adjacent over hypotenuse. So if we let's get down to one triangle here, and let's go over the trig ratios. Okay, and so we can only do one triangle. Let's say we leave the red triangle here. We only need one of the two triangles to work with, and it can be any size we want again, as long as the angles are the same. All of these triangles are similar, so these ratios for the sine, cosine, and tangent are constant for that particular angle that we started with. Okay, and so we see that the sine of the 40 degrees is opposite over hypotenuse, or y over r. I should say the length of the opposite leg over the length of the hypotenuse, but I'm going to shorten that to opposite over hypotenuse, and that's y over r with our standard labeling. The cosine is the length of the adjacent leg over the length of the hypotenuse, or adjacent over hypotenuse for short, and that's x over r. And the tangent of 40 degrees is the length of the opposite leg over the length of the adjacent leg, which is y over x, excuse me, or just opposite over adjacent. And here they are worked out to 5 decimal places, which is probably much, well, definitely much more accurate than what you could get by just constructing and measuring these things. So there are some other techniques for actually computing these to more decimal places to figure out a more exact or a more precise answer. Now, how can we go about memorizing these? Because it's going to be very important that we memorize these ratios, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, or in terms of the letters with our standard labeling, that sine is y over r, cosine is x over r, and tangent is y over x. So this shows some memory tips over here that you can pull this up and read some of these memory tips, but I'll just kind of go over some of them for you. The first thing is sine and cosine kind of sound alike. They are both the ones that use the hypotenuse. Okay, so it's a matter of remembering which one goes with adjacent and x, and which one goes with opposite and y. And the nice thing is you've got some nice alphabetical order going here. C comes before S alphabetically. A comes before O alphabetically. X comes before Y alphabetically. That may help you keep it straight. That's one thing you may help you keep you straight. Tangent sounds different than sine and cosine. It is different. It only uses the legs and does not use the hypotenuse. And so we see that. It is opposite over adjacent. Well, how can we remember which one goes on top, which one goes on the bottom? Well, in our standard labeling, that's y over x, and as I pointed out in our last video, that is just the slope of this line, and you're familiar with slope from your algebra classes, and you may remember that that's y change over the x change, so it's a y over x as well. So the tangent of this angle is the slope of that line if we put it in this kind of standard orientation. Now, other times people will try to come up with some memory little hints, and sometimes people will memorize this by remembering this SOHCAHTOA. S-O-H-C-A-H-T-O-A. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you can't remember how to spell SOHCAHTOA, you can memorize some little sentence that goes with this. Here's one that I heard somebody say. Some old hippie caught another hippie tripping on acid. Okay, make up your own sentence if you don't like that. Whatever. I don't care how you memorize it, but memorize it. So it's very important that we do SOHCAHTOA and whatever. That's not so important. What is important is that we memorize these basic definitions here. A couple other things very quickly. Notice that the hypotenuse is the longest side, so notice that when we do these as fractions, sine and cosine are always proper fractions, meaning the numerator is smaller than the denominator, so that always gives us a number less than 1. So sine and cosine of an acute angle is always between 0 and 1. Tangent for an acute angle is always positive, but it could be, if we put 45 degrees, you'll notice that the tangent is exactly 1, because at 45 degrees we have an isosceles right triangle, and so whatever this side length is, it's the same one here, so that ratio is 1. And if we get bigger than 45 degrees, like 85 degrees, we notice we get a tangent that is rather large, bigger than 1, whereas if we get an angle less than 45 degrees, then we get a tangent that's less than 1. But notice that the sine and cosine are always less than 1. Okay, I think that gives us a good introduction to sine, cosine, and tangent. We'll come back with one more video to practice computing these things without a calculator.